This is not a nice to have, it's essential. This is not a science experiment. We have the technology, it's achievable and central to meeting our climate goals. Hello everyone, my name is Jeff Brown. I'm Managing Director at the Stanford Door School Sustainability Accelerator, and I'm incredibly excited about the Climate Tech Map. I absolutely love working in climate. I came to working in sustainability and climate after many years in Silicon Valley building startups. It became very clear to me that climate is the defining challenge of our generation and also one of the hardest. What drew me in is that it pushes far beyond traditional tech. You have to engage across science, markets, policy, and communities all at once. I like working on problems where the stakes are real and the solutions actually matter at a planetary scale. Carbon removals is still a nascent market, and we still need tremendous innovation to hit our climate targets. We must always remember that removals are not optional, but getting to scale is an unsolved problem. Take mineralization. The science is extremely promising, but we still need innovation across the entire supply chain. This means low-cost sources of alkalinity, low-energy processing, and deployment at scale. Additionally, we need to measure that. And measurement and verification is a major challenge for open systems like mineralization. Doing this credibly will require new sensing technologies, data infrastructure, and AI, and close coordination across the many stakeholders and actors. Finally, we need innovation in markets and finance. How do we transact, finance, and scale these systems globally? That's what makes this space both hard and incredibly exciting to achieve our targets. Carbon dioxide removal, mineralization, is the act of taking geological alkalinity and have it react with CO2 in the atmosphere to capture that CO2 durably across millennium. What we do is we take rocks and minerals that are readily present in the earth and we grind them down into small particle size to increase their surface area to make them readily reactable with that CO2 and enhance that capture process to make sure we can measure it, transact it, and store that CO2 and ultimately scale this industry. In order for us to reach gigaton scale and mineralization, there's a number of innovation imperatives. First, we need to think about our supply chain for geological alkalinity. Here we look at where are there massive sources of alkaline material from naturally occurring rocks to industrial byproducts. Things like mining waste streams, mine tailings, and industrial slags are one promising source, offering a pathway to repurpose existing materials without additional extraction. But to get to multi-gigaton scale, unlocking new primary sources of alkalinity may be necessary. By improving how alkaline endpoints are sourced, prepared, and delivered, innovators can make both enhanced rock weathering and ocean alkalinity enhancement far more effective and unlock a scalable pathway to durable carbon removals. Another critical innovation area for mineralization is verification systems. Building reliable measurement, reporting, and verification for open system carbon removal is hard. These approaches, like enhanced rock weathering and ocean alkalinity enhancement, remove CO2 in natural environments where carbon flows are difficult to track. Measurement, reporting, and verification, known as MRV, are needed to prove how much carbon is truly removed and stored. Reliable MRV builds trust, creates market confidence, and enables large-scale deployments by giving investors, regulators, and communities the assurance that the climate benefits are real and transactable. We love to talk about moonshots and how do we achieve gigaton scale at speed and create impact in this field. One way to do this is supercharging the rocks. How do we reduce the time to mineralization and CO2 absorption from the current state of potentially years and get it down to months, weeks, and even days? And finally, one of the moonshots here is how do you build businesses? What are the co-benefits that we can use and monetize through the act of mineralization? There's tremendous opportunity through using the rocks as fertilizers, or even if you think about it as abating environmental pollution problems. There's a lot of advice I'd like to give people considering coming into this field. I was new on this journey just a couple of years ago, and what struck me is how open and collaborative it is. Carbon removal needs expertise across many disciplines. We're talking science, engineering, policy, finance, community engagement, and operations. What matters most is curiosity, the ability to learn quickly, and creativity. This is a long game. People have been working on these problems for decades, and the opportunity now is to build on that foundation while recognizing how much work still lies ahead. Carbon dioxide removal isn't a space that everybody's familiar with. The one thing I want everybody to understand is that this is not a nice to have. It's essential. Some sectors will always be hard to abate, and in others, removals may ultimately be the most cost-effective pathway. This is not a science experiment. We have the technology, it's achievable, and central to meeting our climate goals.